Hi everyone, Assalamualaikum. In this video, we will discuss the topic of integration. Integration or anti-differentiation is the reverse process to differentiation, right? First, we look at the notation of integration. Alright, the integration symbol is an extended S for summation, the idea of summing slices. Okay, let's say we have integration of 2x dx. Okay, this is called integral symbol. This is integrand, the function we want to integrate. Okay, dx here means slice along x, means we integrate with respect to x. Okay, after the integral symbol, we put the function we want to integral of. Okay, we call as integrand. Okay, and then finish with the x here to mean the slice go in the x direction. Here is how we write the answer. Okay, let's say we have integration of 2x dx. Okay, it is equals to x squared plus c. Alright. Alright, plus c. Okay, from integration of 2x dx equals to x squared plus c. Right, this is called constant of integration. Okay, we wrote the answer as x squared plus c. Okay, but why plus c? Okay, it is the constant of integration. It is there because all the function whose derivative is 2x, let's say we have integration of 2x dx equals to x squared plus c. Okay, when we move integration sign to right hand side, we have derivative because integration is an anti-differentiation, okay, or anti-derivative. So when we move integration to right hand side, we have derivative of x squared plus c. Alright, let's say if we differentiate x squared plus 1, okay, it will give 2x. Okay, let's say we differentiate x squared minus 3. It also gives 2x. Okay, and let's say if we differentiate x squared plus 5, it also gives 2x. Okay, so the derivative of x squared plus 1 is 2x. The derivative of x squared minus 3 is also 2x, and so on. Because the derivative of constant equals to 0. Okay, so when we reverse the operation to find the integral, we only know 2x, but there could have been a constant of any value. So we wrap up the idea just writing plus c at the end. Right? As I mentioned in the previous slide, integration actually is an anti-differentiation, which reverse process to differentiation. By now, you will be familiar with differentiating common function and will have the opportunity to practice many differentiation techniques. In this unit, we carry out the reverse process of differentiation, right? Right now, we look at table of indefinite integral. Okay, throughout this table, a and b are given constants independent of x, and c is a constant of integration. The table gave a list of differentiation of common function we had learned at that point. We restate part of that list here to stress the relationship between differentiation and integration. Okay, this list will also be useful as a glossary of common integrals as we learn. Okay, the left column shows common differentiation rules, and the right column shows common indefinite integration rules. Okay, when we differentiate constant, it will give 0. Okay, let's say we integrate 0. Okay, we will have constant because integration is an anti-differentiation or anti-derivative. Okay, let's say when we differentiate constant a, okay, we also have 0, But when we integrate constant a, we will have ax plus c. Okay? When we differentiate 1, it gives 0. But when we integrate 1, we have x plus c. When we differentiate x, we have 1. But when we integrate x, we have x squared over 2 plus c. When we differentiate x squared, we have 2x. And when we integrate x squared dx, we have x cubed over 3 plus c. When we differentiate square root of x, first we change into the exponent. Okay? Then we differentiate. So we have 1 over 2 third x. And when we integrate, we also need to change to the exponent first. And then we integrate, then we have 2 third x plus c. Okay? Why we get this? Okay? We will discuss later. Okay? Before that, when we differentiate any constant, okay, it will give 0 because derivative of any constants equals to 0. Okay, and from here, okay, in differentiation, the power will decrease 1. Okay, from here. Okay, however, in integration, the power will increase 1. Okay. Alright, now we continue with next rule. Okay, when we differentiate x to the power of n, we have nx to the power of n minus 1. And when we integrate x to the power of n dx, we will have x to the power of n plus 1 over n plus 1 plus c. Okay, for derivative, n here means for any values of n. Okay, but for integration, n here means not equals to negative 1, means any value except negative 1. Okay? Alright. If n equals to negative 1, okay, when we integrate x to the power of negative 1 dx, we need to write integration of 1 over x dx, and it will equals to ln x plus c. This is for n equals to negative 1 only. Okay? And then for derivative, when we differentiate ln x, we have 1 over x. That's why when we integrate back 1 over x, we will have ln x, okay, plus c. Okay. From integration formula, okay, there is no formula for integration of ln x dx. Okay. But we have formula for derivative of ln x, which is equals to 1 over x. Okay. But under integration, we don't have integration formula for ln x. So how to integrate ln x? Okay, we use integration by part. Okay, you will learn in calculus 2. Alright. Okay, when we differentiate e to the power of x, it will give e to the power of x back. Okay. Alright, since integration is the reverse process of derivative or differentiation, so when we integrate e to the power of x, we also get back e to the power of x, and then we put plus c. Okay? When we differentiate e to the power of ax, we have a e to the power of ax. Okay, we multiply by constant a in front. But when we integrate e to the power of ax plus e to the power of ax dx, so when we integrate, we have 1 over a, e to the power of ax plus c. Okay? When we differentiate a here means constant, a to the power of x, it will equals to ln a times ax. And when we integrate ax dx, we have 1 over ln a times ax plus c. When we differentiate e, we will have 0 here. Okay? Because e means constant 2.718 something. But when we integrate e dx, we will have ex plus c. Okay, when we integrate e only with respect to x, we have e times x plus c. But when we integrate e to the power of x, we have e to the power of x back. Okay, plus c. Okay, and notice that in differentiation, when we use power rule, the power will reduce 1. Okay? Alright. However, in integration, when we use power rule, the power will increase 1. Okay? But power rule for integration, n must not equals to -1. If n equals to -1, we must use ln rule. Okay? And E here, okay, means Euler numbers, which is equals to 2.718 something. Okay? Alright, now we look at differentiation and integration of trigonometric functions. Okay? The left column is common differentiation rule for trigonometric function, and the right column is common indefinite integration rules for trigonometric functions. Okay? Alright, first, derivative of sine x. Okay? It will equals to cos x. And when we integrate back cos x, we will have sin x. And we put plus c at the back. Okay? When we differentiate cos x, we have negative sin x. Okay? We have 6 trigo ratios here. Okay? And when we integrate sin x, we have negative cos x. Okay? Alright. From here, okay, you must be careful because when we differentiate sine, okay, we have positive cosine. But when we integrate sine, we have negative cosine here. Okay? And when we differentiate cosine, okay, we will have negative sin x. But when we integrate cos, we have positive sine. Okay? So you must be careful. Okay? Differentiate sine, we have positive cos, but integrate sine, we have negative cos. Okay? Alright. And then when we differentiate tangent x, we have sec squared x. Okay? So we can create formula for integration. When we integrate back sec squared, we will have tangent x. And then when we integrate cot x, we have negative cosec squared x. And when we integrate back cosec squared x, we will have negative cot x plus c. When we differentiate sec x, we have sec x tangent x. And when we integrate back sec x tangent x, we will have sec x plus c. Okay? And then when we differentiate cosec x, we will have negative cosec x cot x. And when we integrate back cosec x cot x, we will have negative cosec x plus c. Okay? Alright. To memorize the formula for derivative, when the answer start from CO, okay, cosec squared on a cosec x, okay, so we have negative sign here. Okay? And for integration also, okay, when the answer start from CO, okay, so we have negative sign here. Okay, we have 3 negative sign and 3 negative sign for integration and differentiation rules. Okay. Alright, throughout this table, A and B are given constant independent of x, and C is a constant of integration. Okay, this is formula for common differentiation rule for trigonometric function, and this is common indefinite integration rule for trigonometric function. Okay, let's say if the angle is given in terms of linear. Okay, so when we differentiate sine ax plus b, okay, ax plus b means linear, so we must multiply by a, constant a in front here. Okay, but when we integrate cos and then the angle is linear function ax plus b, we have sine ax plus b, which is linear, and in front we must multiply by 1 over a. A here means coefficient of x. Okay, and then must put plus c. Okay, from here, if the angle is linear function, so for derivative, we must put times a in front. But for integration, if the angle is linear, okay, we must multiply by 1 over a in front. Alright? And then for derivative, okay, we have 3 negative symbol, okay, when we differentiate. And for integration, when we integrate, we have 3 negative sign here. Okay, after we integrate, 3 negative sign and 3 positive sign. Okay, same goes to differentiation. Right? Right. Now we continue with next rule. Okay, if we differentiate tangent x, we will have sec squared x. Okay, but for integration, when we integrate tangent x, there is no direct formula to integrate, okay? But we need to change to basic trigonometric function, sine and cos. Then we can use u substitution. We will discuss later. And the answer is negative ln cos x when we integrate tangent x. Or we can write ln sec x plus c, okay? And when we integrate cos x dx, we need to change to basic trigo function, which is cos over sine. Okay, so we will get ln sine x plus c. Okay, after we use u substitution, or we can write negative ln cosec x plus c. Okay, excuse me. Okay, and then when we differentiate sec x, we have sec x tangent x, but under integration, when we integrate sec x, we will get ln sec x plus tangent x plus c. Okay, when we differentiate cosec x, we have negative cosec x cot x, and when we integrate cosec x dx, we will have ln cosec x minus cot x plus c. Okay, this formula actually in calculus 2, not in syllabus calculus 1. Okay, alright. When we have constant in front, okay, we can move out. Okay, this is multiplication by constant. A here mean constant, so we can move out the constant. Okay, but never move out variable. Variable means x, u. Okay, and if we have in between plus or minus sign, okay, we can integrate using sum and difference rule. Sum and difference rule means we just integrate one by one. Okay, alright, when we have constant in front, we can move out. When we have in between is plus or minus sign, we just integrate one by one. Okay, and when we integrate tangent x, the answer not equals to sec squared x, but we need to change to basic trigo, means sine and cos. Then we use u substitution. Then after that, we will get answer negative ln cos x plus c, or when we change to reciprocal function, we have ln sec x plus c. Okay, and same goes to integration of cot x dx. If we want to integrate cot x dx, the answer not equals to negative cosec squared x, but we need to change into the form of cos x over sin x first, then we use u substitution, then after we integrate, we will have ln sin x plus c. Okay, we will discuss later here. Okay, coming up next, indefinite versus definite integrals. You can subscribe if you like this video. Thank you for watching. Stay tuned. Bye. Assalamualaikum.